There are a number of times when you're going to be dealing with large data sets and you're going to have to repeat calculations over and over and over again. And that's a waste of our time in order to have to repeat things over and over and over again now that we have computers that can do those repetitive tasks for us. So there are a lot of tools that we can use to automate things. My general principle is if you're going to have to do something more than twice, you should automate it. Excel is a good tool for a lot of basic automation, and it's one that shows up on computers all over the place, and there are other spreadsheet programs that are similar to it. So we're going to be using that in our course, but having some of these skills will be useful for you across a number of different courses and disciplines and things that you'll do throughout your life and career. So let's take a look at how to automate some things in Excel. And so I'm just going to set up an example, and I want to show you a couple of things. So let's say I wanted to look at different wavelengths of light. So I'm going to put wavelength here, and I'm going to, of course, tell what my units are, put my units in parentheses to indicate those are units. You'll notice that I just double-clicked on the border here, and that expanded this to fill the cell. And I'm just going to type in some numbers. So I'm going to put 200 and 300, and already I'm at a point where I can have Excel automate. I could keep typing 400 and so on, but let's say I just wanted things evenly spaced. I can highlight a couple of these. Excel will recognize this pattern that I'm adding 100. I grab this little box with my mouse, and I drag it down, and Excel will fill in the rest of the pattern there for me. Okay? So let's say I wanted to convert from wavelength to frequency, and let's say I wanted to do it a whole bunch of times. I know that the speed of light is equal to the wavelength times the frequency, and so I could solve for frequency, and I'd see here that the frequency is the speed of light divided by the wavelength. So I could use my calculator and I could type in 3 times 10 to the 8, and I could divide by the wavelength to get the frequency. Right? But I don't want to do it a whole bunch of times, so I'm going to make Excel do it for me. So here I'm going to put frequency, and I'm going to put my units, which will be hertz, which is the same as 1 over a second. And I'm going to type in here, and I'm going to say, okay, is equal to the speed of light. And this equal sign that I've just entered, this tells Excel that I'm not typing a number into this. I'm not typing a value. I'm actually typing in a formula. So I'm going to hit equals, that tells it it's a formula, and now I'm going to type in the speed of light, which is 3.0 times 10 to the 8. The way I'm going to tell Excel that, I really want to avoid typing times 10 to the, it gets very confusing when you start to type long formulas, so instead I'm going to hit E8. When I do that, that's the same as 3 times 10 to the 8. So I'm going to type that in, and now I'm going to divide by the wavelength. Okay, now I could type in 200 here, but there are a couple problems with typing that in. One is then I'm going to have to type it over and over again. The other problem is it's in nanometers, and when I look here, I've got my speed of light in meters per second, so I need to be dividing by meters in order to give me 1 over seconds, which is a hertz. So I have to be careful about my units, so that's one thing that I'm going to do. But the key trick here is now I'm going to click on this cell while I'm typing my formula. And it's now, instead of putting a 200 here, it's going to put this A2 that says it's in column A, row 2, and it's going to refer to that cell when it does the calculation. Now the other thing, at the same time I need to convert this into meters, so I'm just going to multiply by 10 raised to the 9, rather minus 9, and that's going to convert from nanometers to meters. So now I've got this formula in, and it's going to do the conversion and do the calculation for me. So I get 1.5 times 10 to the positive 15. Okay. Now, I could type that formula in again. I could start typing equals 3.0, but then that's again a waste of my time. So what I'm going to do is I'm going to click on this cell, and I can drag this down, and it's going to fill in the same formula again for me, or I can just double click on the corner of that box, and it's going to fill the whole column in for me. And if you look at the formula carefully here, you'll see this refers to cell A2, this one refers to cell A3, this one refers to cell A4, so it's always pointing at these. Also, if I double click, it'll really make that clear for me. It's referring back to this cell. Okay, so I'm going to hit escape to get out of that. So it goes on down the line and does all those calculations for me. And so that's going to give me the frequency. Okay, so now I'm going to do some additional things. Let's say I wanted to find the energy in joules. I've got a number of different formulas that will give me the energy. One of those is the energy is equal to the Planck's constant times the frequency. That's one formula for the energy of a photon. Or alternatively, I can relate it to the wavelength as hc over lambda. Okay, the energy is Planck's constant times the speed of light divided by the wavelength. So that's another formula I can use. I'm just going to go ahead and use this one here. That's the simplest one because I've already got the units in the right format. So I'm going to click here, and I'm going to say equals, because I want it to be a formula again. I'm going to type in Planck's constant, 6.626 E minus 34. That's Planck's constant. and then I'm going to multiply it by the frequency. So again, I just click on this reference cell here. I hit enter, it's going to fill in the value for me, and then I can just double click or drag it down, and I'm going to get all my values for my energies in joules. Okay. Pretty slick. I've done a whole lot of calculations with very, very little work. Okay, so now let's see, how could I look at this data graphically? Let's say I wanted to plot the wavelength and the energy. I'm going to put the energy on the y-axis and the wavelength on the x-axis. I'm going to click on one of these, and I'm going to hold down Control, and I'm going to click on another column heading. If I click on the number at the letter at the top, it'll select the whole column for me. And I'm going to now go and I'm going to say Insert, and I want a scatter chart here, and I want a normal scatter plot. Okay, and instantly I've got a graphical representation if I've got the wavelength on the x-axis and the energy on the y-axis. It won't always put things exactly where you want them, and so we're going to have to make some modifications. Excel is optimized for finance rather than for scientific application. It works great for scientific applications, but we have to tweak things a little bit to make things look the way a scientist would normally interpret them. Okay, so there are a couple things that I'm going to do here in order to make this work out well. One thing that you'll notice immediately if you look at the y-axis here is that there are no values showing up on the y-axis, which is a problem. This is because Excel will only plot values between 10 to the minus 15 and 10 to the 15. Older versions of Excel used to handle this properly. I'm not sure why they changed it. So there are a lot of ways we could deal with this. The simplest way to deal with this is just to recast our energy in a different unit. So I'm going to redo my energy here, and I'm just going to do it in nanojoules because that's going to put me in a number range that will work better. So I'm going to make another formula, and I'm going to take this, and I'm going to multiply this cell here. I clicked on it, or you can use your arrow keys also. And I'm going to multiply by 10 raised to the 9. And that's going to go from joules into nanojoules. Now you'll notice I'm between that 10 to the 15, 10 to the minus 15 range. Okay, so I'm going to click on my formula, double click on the corner, it's going to fill everything in for me. Okay. Now, I could delete this plot and make a new plot with these other columns, or there's a more efficient way. Once I've got a plot going, I can right click on it and I can tell it I want to select data. And once I do that, then I'm going to click on Edit within the series here. This allows me to choose my X and Y values. So this also works if you've got the wrong thing on your X-axis. So if I click on this little button here for Series X values, I can look here and it's going to plot. It's got these values selected for my X. Okay. I can also look at my Y values. And now instead of energy in joules, let's do energy in nanojoules. And immediately you're going to see it plots these values on the axis. So I'm going to say OK a couple of times, and it's going to fill this in for me. Okay. Now, there are a couple things that I'm going to do to clean this up. One is this legend here is useful if I've got multiple sets of data plotted, like this one with blue diamonds and another one with red squares or something, but I've only got one piece of data, so this is just wasting space that I could be using to spread out my graph, so I'm going to just click on it and delete it. There are often times where you're going to want titles on graphs. I'm going to get rid of this one because I'm going to put more descriptive labels on the axes. We'll do that in just a moment. One thing that you'll notice here is that my data is not linear, and oftentimes that's okay, but it's sometimes more difficult to interpret nonlinear data. There are tricks for doing it, but an easier way to go about doing things is to make our nonlinear data linear. And this is a really useful tool to have in your bag of tricks. So let's look at how we might make this data linear. Right now, on my y-axis I have the energy plotted, and on the x-axis I have the wavelength plotted. Okay. So basically I've got energy and wavelength with some constants. So this is the formula that I'm going to refer to. Okay. If I take this formula here, and I want to rewrite it in the form of a line. So a line has the general form y equals mx plus b, where m is the slope and b is the y-intercept. And I'm going to take this formula and I'm going to rewrite it a little differently. I'm going to rewrite it down now as E equals hc times 1 over lambda. And if I do that and I look now here, I've got y. Okay, that's my energy, so I can plot the energy on my y-axis. Okay, and now I've got a slope, m, that is h times c. And now if I were to plot my x as 1 over lambda, then I'm going to get this is my slope. So right now my current x is lambda, it's my wavelength. Let's change it to 1 over wavelength, and we should get something that's in the form of a line. Okay. You'll notice I'm missing a plus b here, so we can just say plus 0, right? That's the part that's missing. Okay, so let's go to Excel and let's do that. So I'm going to make another column, and I'm going to call this column 1 over the wavelength. So that'll be 1 over nanometers for the units. And I'm going to double click here to expand this cell. And now I'm going to say equals to make my formula, 1 divided by, and I'm going to click on the wavelength. Okay, and I'm going to then hit enter, okay, and I'm going to get 1 over the wavelength. And when I do that, now I can go right click on this again and do this same select data. I'm going to edit this. I'm going to choose my x values now, and instead I want my x values to be 1 over the wavelength. And immediately you can see I've got linear data here. Okay, so I'm going to say OK, and I'm going to say OK again. And so now I have this nice straight line, which is going to be a lot easier for me to interpret. Okay, before we go about interpreting it, let's do a couple things that make the graph more readable. One is these numbers mean nothing to anyone who's just looking at the graph. We need to tell them what those mean. The way you do this varies from version of Excel to version of Excel, but on my version of Excel, I'm going to go to Chart Tools, Layout, and I'm going to tell it that I want axis titles. So I'm going to tell it I want a horizontal axis title, and you'll see it insert. And I'm going to tell it that I also want a vertical title. I'm going to tell it, axis titles. I want to tell it that I want a rotated title, that way it looks nice and clean. Okay, so I need to tell somebody what are these things on this axis. So I'm going to take my y-axis here and I'm going to tell it that this is energy, and it's always really important that I put the units on the energy. So this is nanojoules, the way that I've plotted it. Okay, and now I'm going to go to this one here and I'm going to say this is 1 divided by the wavelength, and that's in 1 over nanometers. Now, there's another way we could write this, and I'll show you a couple little tricks. If I type nanometer minus 1, I can select all this here, and I can right-click on it, and I can tell it that I want to change the font to a superscript. So now I can make nanometer raised to the -1 power, which is the same as 1 over nanometer. Another little trick that I can use is instead of typing out wavelength here, I could change this to the symbol for wavelength. So I could put 1 over, and I can go to Insert. I can tell it I want to put a symbol in, and then I can find the Greek symbol lambda, and I can insert that, and now I've got 1 over lambda. So that's another way that I can do things. But you could use the descriptive word wavelength there as well. Okay, so now I've got a nicely labeled thing. Sometimes you don't want these grid lines in here. Sometimes they just make things a little more confusing. Sometimes you might want those, but those are things that you can get rid of as well. So this is a really nice, clean looking graph. So let's interpret it. So what I'm going to do is I'm going to click on my data, and I'm going to right click on it, and I'm going to say add trend line. Okay, and I want to choose a linear trend line, and I want to do a couple extra things. I want to display the equation on the chart, and I want to display the r-squared value. This is one measure of goodness of fit. It's just telling me how well does my line go through my points. Notice I get a 1 here. 1 means that it goes through perfectly, but that's because this is contrived data. Experimentally, you'll almost never get 1. Okay, and so now I'm going to say OK. Now the problem with this is by default the precision is really poor in this. Okay, I'm going to make this a little bigger first of all, so I'm going to select all this, and I'm going to just tell it that I want to make the font a little bigger, since I have it sometimes ends up really small, especially when I print this thing. So I'm going to right click on this, and I'm going to say Format Trend Line Label, and that's going to allow me to put more precision in this. Sometimes you want to choose number. Here I'm going to choose that this is a scientific number. Actually, I need to just do that again. So Format Trend Line Label, and I'm going to tell it that I want a scientific number, and I can tell it how many decimal places that I want. And when I do that, oh, we're having an issue with our trend line label. Let's try that one more time. Oh, sorry, I need to actually click on my trend line itself. Oh, no, it appears that it should be the trend line label. Okay, let's go try scientific. Okay, so I've got it working now, so I am in my format trend line label. I'm going to tell it that I want scientific, and now I can choose how many decimal places I want it to have. So I can say I want it to have 3 decimal places, and it'll fill in to give me more decimal places when I do that. So I've got that, and now I can use this to do some meaningful interpretation of data. So let's see how we might interpret that. Okay, so now when I look at this, I've got this y equals mx plus b, and it looks like this. It looks like y equals 1.988 times 10 to the minus 7 times x, and then this is essentially plus 0, right? So I'm just going to put a plus 0 here because that's such a small number. And so now let's figure out, how do I interpret this? So this here, remember, this is my slope, this value here. So that's the meaning of the slope. So let's look at that a little more carefully. So I've got 1.988 times 10 to the minus 7, and the units on that are going to be, a slope is always rise divided by run, right, or y divided, change in y divided by change in x. So that's going to be nanojoules divided by 1 over nanometers, so that's going to be times nanometers. Okay, so I divided by 1 over nanometer, and so that's all equal to hc. Okay. Now, one issue with these units is that I've got nanojoules and nanometers, and normally we want to get back to the base SI units, so I could do that by going like this, times 10 to the minus 7 nanojoules times nanometers, and then I'm going to get rid of nanojoules and go to joules, and I want to get rid of nanometers and go to meters. I know they're 10 to the 9 nanojoules in a joule, 10 to the 9 nanometers in a meter, and so when I recast this here, now I've got 1.988 times 10 to the minus 18 down here, so this becomes minus 25 joule meters. Now, what in the world does that mean? Well, let's compare it to the known values for h times c. All right, so if I take h, which is 6.626 times 10 to the minus 34 joule seconds, that's Planck's constant. If I multiply it by the fundamental constant, the speed of light, 10 to the 8 meters per second, and I look here, then what units cancel out? My seconds cancel, and I'm left with joule meters. Okay? And I get 1.99 times 10 to the minus 25 joule meters. Right? That matches what I was able to extract from my graph here. Okay? So we're going to be able to do lots of meaningful interpretation like this. Sometimes you're going to pull data out of the y-intercept. Sometimes you're going to pull data out of the slope. The slope tends to be the more reliable of those things. Okay. Just one other trick that I'll show you real fast is sometimes your data doesn't fill the chart very well. Excel likes to pick where it places things, and sometimes it's not where you want it to be. So if I right-click here or double-click on my horizontal axis, then I can tell it that I want to choose where this thing starts and ends. You can do this on both the horizontal and the vertical axes. I'm on the horizontal one right now. So instead of letting it choose it automatically, if I needed to fill my graph in a little better, I could tell it, let's start instead at this value here, and that's going to cause my data to shift over and get closer to the axis. Now the increment is set to auto, so I'm not going to get clean increments when I do that, so you might need to mess around with that a little bit, but you always want your data to fill out the spacing well. You don't want to waste a lot of white space in a graph. All right, so that's just a quick run through of the ways that we can use Excel. There are a lot of other powerful things that you can do with spreadsheet programs, but this gives us the basics of how we might put together a graph and deal with some basic formulas.